In this problem, we need to solve the equation log to the base 3 of the quantity x plus 1 plus log to the base 3 of the quantity x minus 2 equals log to the base 3 of 4. Well, what type of equation is it? Well, obviously, it's a logarithmic equation, but what type of logarithmic equation? If you notice, this term is a logarithm, so is this one, and so is this one. Are the bases the same? Yes, base 3, base 3, base 3. So this is the type of logarithmic equation where every single term is a logarithm. And how do we solve those? So if every term in the equation involves a log, then we need to use the properties of logarithms to combine our terms and get log to the base b of m equals log to the base b of n. Notice what coefficients in front of each of the logs are 1 and the bases are the same. Then we can use the one-to-one property of logarithms that says if log to the base b of m equals log to the base b of n, then m has to equal n. Finally, after step 2, we solve the resulting equation for the variable, and don't forget, you must check your answer for extraneous solutions. So step 1 is we need to get our equation to look like this. 1 log on one side equals 1 log on the other. So going back and looking at our equation, unfortunately, we have 2 logs on this side. So we're going to have to combine them using the properties of logs. So on the left-hand side here, I have 2 logarithms that are added to each other. So I'm going to have to use the product property of logs that is shown here that says log to the base b of a product is equal to the sum of the individual logs. So I have the sum of 2 logs, so I'm going to use this property going in this direction. So I'm going to have, in my case, log to the base 3 of, instead of 2 individual logs, I'm going to have the log of a product. So I'm going to multiply my 2 arguments of x plus 1 times x minus 2. And that has to equal log to the base 3 of 4. So now, as I have a 1 in front of each of these logs and the bases are the same, I can use the one-to-one property of logarithms that says if log to the base 3 of this product equals log to the base 3 of 4, then that product, x plus 1 times x minus 2, has to equal 4. So now, what type of equation do we have here? Don't be tempted to set each of these factors equal to 4. That only works if I had a 0 on this side. That's the 0 factor property. So what I'm going to have to do is FOIL out these 2 binomials, collect all the terms on one side, and then factor or use the quadratic formula. So let's FOIL it out quickly. X times x is x squared. X times negative 2 is negative 2x. 1 times x is plus x. And 1 times negative 2 is negative 2. And that has to equal 4. So I get x squared minus 2x plus x is minus x minus 2 equals 4. This is a quadratic equation. I need to get 0 on one side, so I'm going to subtract 4 from both sides. So I get x squared minus x minus negative 2 added to negative 4 is negative 6 equals 0. So now we're going to try and factor it. And remember, we need to figure out a, b, and c. So a is equal to the coefficient of the x squared is 1, b is the coefficient of the x is negative 1, and c is the constant negative 6. I need two numbers that multiply to a times c. That's 1 times -6, which is -6. So I need two numbers that multiply to -6, and they need to add to b, which is -1. Since they multiply to a negative, the signs are opposite, and since they add to a negative, the bigger one has to be the negative. So I'm going to try 1 and -6. Those multiply to -6. 1 plus -6 adds to -5. Not what I want. 2 and -3. What's 2 plus a -3? -1. That's what I want. So these are my factors. Since a was equal to 1, I don't have to split the middle term down. These are my factors. So I'm just going to have x plus 2 times x minus 3 equals 0. Two numbers multiplied together equals 0. You set each of them equal to 0. So x plus 2 equals 0, and x minus 3 equals 0. So this one, first one, subtract 2 from both sides, x equals -2. And the second one, add 3 to both sides, x equals 3. And a lot of students stop at this point, but remember what we showed in our notes here. You must check for these extraneous solutions. As I was running out of room, I've written my original equation up here and the two solutions I found that I need to check. So let's check x equals -2. So I'm going to have log to the base 3 of x, what's x? -2 plus 1. And when we check for extraneous solutions, all we have to check is to make sure our arguments are positive numbers, because the domain of a logarithmic function is positive numbers. So what's -2 plus 1? -1. Is that positive? No. Therefore, x equals -2 is an extraneous solution. Notice, once I found the first argument that messed up, I didn't have to check anymore. I'm done for that value of x. So now let's check x equals 3. So I'm going to have log to the base 3 of 3 plus 1. 3 plus 1 is 4. Is that positive? Great. Plus the next term here, log to the base 3 of x is 3, so it's 3 minus 2. 3 minus 2 is positive 1. That's positive. Excellent. Equals log to the base 3 of 4. Is that positive? Yes. So since all the arguments are positive, I've shown that 3 is not extraneous. I haven't proved its correct solution. To do that, I have to finish the check. I'd have to do log to the base 3 of 4 plus log to the base 3 of 3 minus 2 is 1 equals log to the base 3 of 4. Now, since these two logs are added together, you multiply the argument, so you get log to the base 3 of 4 times 1 is 4. Does that equal log to the base 3 of 4? That is a true statement, so I have shown that this is the correct solution. However, you don't have to prove this part down here. All you have to do is prove it is not extraneous.